Hi everyone. In this lecture I will teach you that how we can change the feed width and the feed length through parametric sweep, and we will see the impact of changing these variables. As in the previous lecture, I designed an antenna for 13 GHz and I was just only using the parametric sweep on the feed on the patch width and the patch length. So I will save these previous results. I will save it from here. I will go to file and I will go to save as I have already saved it with this name. So now I will change the feed line width and the feed line length, and I will see that what is the impact of this parametric sweep on the antenna results on the reflection coefficient, or we can say that S11. Previously we changed these variables and we have seen the impact. We have defined W equal to 7.8 and L equal to 4. Through parametric sweep we identified these values of the variables. Now we will do and change FL and FW. Go to parametric sweep, delete the previous data, create a new parameter, and a new parameter this time will be the feed width, which is FW. So I will start from 0.5 and I will stop on 3.5. and I will use the step size of 0.5. So with this step size, I will get 7 linear results. So for 7 different samples of the feed width, I will get results, and the results will be the S11 coefficient. So I will start the simulation, and when the simulation started, the feed width is minimum, which is 0.5, which is the first sample value of the feed width. And as the simulation proceed, this feed width would increase. First it will be in the second simulation it will be 1, in the third it will be 1.5, 2, 2.5, 3, and lastly it will be 3.5. So with each simulation get completed, I get results of the S11 parameter, which is stored in the 1D result section. So this is the last experiment. As you can see, the 7th linear result has been created. So now I will go and I will check the S11 parametric results, and I will see that what happened there. So I will go to the 1D result section on the left side, and I will open the S parametric results. So these are the results. I will go to the 1D result of the S parameter and open the result navigator, and here you can see that the feed width is changing. So here you can see that the feed width is changing. This is for 0.4, for 0.5, this is for 0.5. The feed width is 0.5. Here the feed width is 1, and it is 1.5, then 2, and then 3, and lastly 3.5. So as we have observed that when I narrow the feed width, like when it is 0.5, the operating frequency is high, but when I increase the feed width, the operating frequency shifted to the lower side. So I'm going to check that which one should I select, because for the 0.5 the antenna is operating at nearly 13 GHz. There is another band at 18 GHz, but I am interested in 13 GHz, so it is not purely at 13 GHz but slightly shifted. So I will check the simulation result from 10 to 15 GHz, and in that range I get 0.5 is the best parameter. I can also take 1, but 1 is slightly more shifted towards 12 GHz. So I can take 0.5 as the feed width. So I will fix this value in my parametric list. I will write 0.5 here. So I will save this value and I will update the parameter from here. Now you can see that the feed width is narrow. I will go to the modeling again. I will go to the simulation again. from the frequency section, I will fix the frequency from 10 to 15 gigahertz because I don't need the results at higher frequencies. So I will save this value. Now you can see the dimension of the feed width is given. I will delete the previous results, and then you can see that I have these different results. So I need to delete all of them. From here, the results is still preserved within the 3D geometry. You can see that if I rotate this antenna, now the width of the antenna of the page is 7.8. I will start a simulation again so that I may see the result for this fixed parameter. So I'm going to get one result. Now the simulation process is completed, and I have observed that for feed width of 0.5, I get a little more desired results. So I will go to the S parameter and I will open the result. These are all the results, but I am interested in only one result, which is this one. So you can see that from 10 to 15 gigahertz, the antenna is slightly lower shifted from 13 gigahertz, but still it is, compared to other parameter, it is more near to 13 gigahertz. So the band, which should be lower than minus 10 dB points, so it is like 0.1 or 0.1 gigahertz. I think it is 1 gigahertz band approximately. So now I will change the other parameter and through parametric sweep procedure, and I will see the result. So I am interested in changing the feed length now. So I will go to home and I will click on the parametric sweep. I will delete the previous settings. Now I will define a new parameter, which is the feed length, and I am interested in changing the feed length from 5, and then I'm going to decrease it to 0.5. So for this I will get 4 linear results. I will check this and I will start the simulation for these settings. So for the total of 4 samples of the feed length, I will get results. So this is our first experiment. The feed width is constant, but the feed length will be changing. So you can see that the simulation process is completed and I have got my results. Now I will observe the results, that what is happening. So you can see here, this is the ground plane. As I have changed the length of the page, so length of the feed line, now I am going to verify that what changes has occurred. So you can see that the feed line length has increased and it has reached to almost the center of the page. So you can see that this is an extra increase in the feed length. So now I will see that what is the impact of this changing on the antenna results. So I will see the performance. I will go to the result navigator, and you can see this is our first feed length, which is 3.5, and you can see that this is our S11 result. And for the 4, I get almost the similar results. So for all these variables, for all these values of the feed length variable, I get almost negligible change. So there is almost negligible change, or we can say that there is no change. So as I have changed the feed line length from 3.5 to 5, but I see that there is no any change. So now I will change it from 3.5 and I will change it to 6, variable value 6. So I am going to apply again the parametric sweep. I will change this value from 5 to 6, and the step width should be similar. So I will get approximately 6 results. I think 5 results. So I'm going to start the simulation, and I will wait for the simulation results to see what change has occurred. So it will take a little more time. Then when I get the result, I will show you. So I have got the results. Now let's see what has happened. So I will go to the S parametric results and I will open the 1D results, and I will now go to the results navigator, and this is the first result. So this one is the first result. I'm going to show you one result. So this is 3.5. This is for the feed length 4. This is for 4.5, 5, 5.5 and 6. So now I have observed that by changing the feed line length, no any changes occurring on the antenna performance, or neither any changes occurring on the antenna bandwidth or operating frequency. So I will keep the feed line length as 3.5 as it was previously. So I will update the parametric results. I will update the parameter from here, and now from here, from changing all these variables, I have observed that the feed line length has no impact on the antenna performance. However, the patch dimension is severely affecting the operating frequency, and it is shifting the band towards higher and lower frequency. Similarly, I have observed that the feed width is also impacting the antenna performance. So in the next experiment, I will change further parameters, and I will see the parametric sweep result of those parameter, and I will optimize my antenna in this way. So for this, I have changed the feed width and feed length. In the next experiment, we will change further. Thank you so much.